So now that we've gone over the basics of graph terminology, we can use all that information and apply it to actual problems. So we'll take this information and model it. Here's the Königsberg Bridge problem again. In picture A, we have just the problem with the river and the lands. If you look over at picture B, there's a wireframe now put over that picture where we represent bridges with edges and land masses with vertices. And then in picture C, we can take away that picture completely and just focus on the wireframe, making it a little bit easier to try to work out some kind of solution. The only thing that really matters in this problem is the relationship between the land masses and the bridges and how we can model those. So the question here is which land masses are connected to each other and by how many bridges. So we'll pick a couple of these vertices and talk about them real quick. For example, vertex R. Okay, so vertex R is right here, and it's connected to A and D. Notice that to D there's only one connection, and then in the original picture there's only one way we can get from landmass R straight to landmass D. But from landmass R to get to A, there's two choices. We can take this bridge or this bridge, and in the diagram we have the option of going this way or this way. So, and then look at D. So D has one way to go to R. We can go this way, and in the picture we've already illustrated that. D can also go to A only one way, and then there's only one edge connecting D and L. So there's never a point where D has multiple edges with another vertex. And here, once again, we just have a summary of what's going on between pictures A, B, and C. Remember, A is the original problem. B, we take vertices and edges and put that over our problem, and then take out the picture completely with just kind of that wireframe left. It makes these a whole lot easier to work out and put some numbers down onto. Alright, so here's some example problems or questions to go along with the diagram. So how many odd vertices are there? Well, if we look at the picture on the far right, where we've taken just the vertices and edges out, it's pretty easy to find that. So let's look. We're looking for vertices that have an odd number of edges that touch them. So it looks like we have R. Oops. Sorry about that. We have R, D is an odd vertice, and A, and L. So all four of them are actually odd. R has 3, D has 3, L has 3 edges, and A has 5 edges coming out. So hold on a minute, let's get rid of this for the next question. So our answer to that is going to be 4. How many edges are in this entire thing? So all we really have to do is count those up. So we have here, I'll mark them down. So 1, 2, 3, 4, 5, 6, 7 edges. Okay, so 7 edges total. What is the degree of the vertex at A? A has 5 edges coming out of it, so that's going to be degree 5. And what are the multiple edges? So we have AL, AL, and we also have AR and AR. Those are two sets of multiple edges. And again, what that is when vertices are connected in, directly with more than one edge. Alright, so back to that police or that security officer problem. We're not going to really solve it out completely right now. We're just going to answer these three questions. How many odd vertices are there? So what we're looking for are vertices with an odd number of edges connected to them. So I see, let's label this question as, let's label this as red. So when I see an odd vertex, I'm going to mark that red. So there's an odd vertex. 1, 2, 3, 4. It's another odd vertex. 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's going around the outside. And let's look on the inside. Most of the ones on the inside have 4 edges connecting them. So we've counted up 12. Oh, we have another one here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12 so far. 13, 14, 15, 16, 17. And I think there's one more in this problem. Oh, it's right here. 1, 2, 3. Yep. So that's 18 total. How many edges are there completely? I'll mark a few of them for you, but I'm not going to sit here and do every single one. So again, when you're counting edges, you're just, well, it's as simple as that. You're counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could go on, but I'm just going to go ahead and tell you that there are 55 total edges. What is the degree of the vertex at S? Okay, so looking at point S, it's labeled here on the diagram. We have 4 edges coming out of that, so the degree is going to be 4.